Okay, so in this class, we are going to do more of complex numbers. So our examples are coming from the text of the story. In complex numbers, the key most thing is to understand that I squared is equal to -1. If you know this, then you are done with complex numbers, okay? Because then I know if the power is beyond 2, then I can find a way of using it too. As long as I know that I squared is equal to -1. That's key. So now, let's work out some numbers. Express in the form A plus BI. A, we are given 1 plus 2I squared. 1 plus 2I squared. So when there's a square means multiply that thing by itself. Multiply that thing by itself. Not that you start conjugating, no. So you just multiply 2I multiplied by 1 plus 2I, like this. Okay? That means we multiply, the no multiplication. 1 times 1, we get 1 plus 1 times 2I, we get 2I plus 2I times 1, we get 2I. 2I times 2I, we are going to get 4I squared. Okay? Meaning we have 1 plus 4I, 2I plus 2I, and then I squared is -1. So we have plus 4 times -1. Now -1 times 4 is -4. -4 plus 1, this 1, becomes -3. And then plus 4. This is how you do the expansion of complex numbers. It all lies on the I squared. Okay? Let's do the next one. Let's see the advancement. Now we are given 1 minus I power 4. This is 1 minus I squared. You know, power 4 can be written as 2 power 2, like that. Okay, because we understand that square means multiply by itself, so we can easily break the 4 into 2 and 2 outside. So we know if we multiply those two, we'll still retract our 4. So now, the inside of the brackets will be 1 minus I multiplied by 1 minus I, and then square. Meaning, we'll now have 1 by 1, 1, 1 by minus I, minus I, minus I by 1, minus I, minus times minus to be plus. I times I, it will be I squared. The square outside is still there. So now we have, now we have 1 minus 2I. When we add the minus I, we minus 2I. And then I squared is -1. One minus 1, 0. And then minus 2I. squared. So we have minus 2 times minus 2, positive 4i squared, meaning we'll have negative 4 as our inside thing. So you see, so inside we remained with a minus 2i, then the square came in, you multiply negative 2 times negative 2, it gives us a 4, and then I times I squared, and then I squared is negative, so negative times 4, negative 4. Like that. C, it's 3 plus 2i. 2 minus 5. We multiply 3 times 2, 6. 3 times negative 5, negative 16i. 2 times 2, positive 4i. I times I. So here first we have 2 times negative 5, negative 10. I times I, negative 1. I've now stopped writing I squared. I'm writing negative 1 directly. This we understand now. So negative 10 times negative 1 is positive 10. Positive 10 plus 6, we'll have 16. And then minus 15i plus 4i, that's minus 11i. Expressed in the required form. You see? Very easy to do things. D, 2 minus 3i. Again, now to the power 3. Hey, what happens? Let's see. This means 2 minus 3i squared multiplied by 2 minus 3i. So 2 minus 3i, 2 minus 3i. First, we'll start with this, and then keep 2 minus 3i. Two times 2, 4. 2 times 3, 6. 3 times 2, 6. Negative times negative, positive. 3 times 3, 9. I times I, minus. Like that. Then minus, so 4 minus 9 is minus 5. 6 is minus 12i. You see? So now at this point, we now expand again. So we multiply minus 5 times 2, minus 10. Minus 5 times minus 3 is positive 15i. Like that. 12i times 2, minus 24i. Then I times I, negative. Negative times negative, positive. Then 12 times 3 is 36. So we'll have negative 36. Because these negatives, they have cancelled. So the remaining negative is one coming from the i's. So now we have negative 10 minus 36, negative 46. And then 15 minus 24, that's negative 9. Like that. That's the solution there. So complex numbers, not so complicated. You see?
Sir, I'm kindly asking what do question A.
Can we go through question A?
No, question E.
expression E.
Yes, the one from 1 plus root 2i over root 3 minus 2i.
Right. So we're going to E now. E, the 1 plus root 2i over root 3 minus 2i. So if it's a fraction, then it's conjugation. How do you conjugate? You multiply by the conjugate of the denominator. You change the sign of the I. So instead of minus, now. So 1 by root 3, root 3. 1 by 2, 2i. Root 2 times root 3 is root 6. I times I, negative. So we have minus. Root 3 times root 3, 3. Root 3 times 2, it will be plus 2 root 3i minus 2 root 3i. And then negative times positive, negative. I times I, negative. So I have two negatives making it positive. Then 2 times 2, 4. So now this minus that, 0. So we have root 3 minus 2 root 2 over 7 plus 2 plus root 6 I. So we have factored out, we have factored out, you factor out I, since it's common there, and then you divide by 7, like that. So we are done.
Sir, is it that you have to, what's this, to fact out I always, or you can just leave it like that?
Even if you left it like that, you don't lose a mark.
Or
But the thing is, we factor out I because just want to represent in the required form. Remember, the required form said A plus BI.
I,
Okay, what about F? F is 1 plus 2i over 1 minus I plus 1 minus 2i over 1 plus 3i. So here, these are fractions. We can choose to conjugate separately and get the common denominators later on, or to get the common denominators and then put things together. So let's do the conjugation by pieces. 1 plus I (1 plus I). At the same time, we are conjugating this side. Like that. So we have 1 plus I plus 2I minus 2 over 1 plus I minus I plus 1. Plus 1 because I times I is negative, and there's a negative there making it plus. And then plus 1 minus 3I minus 2I, negative, negative, plus I minus 6 over 1 minus 3i plus 3i, I negative times that negative plus 9. So we get 1 minus 2, that's minus 1, plus 3i over 2 over 2, because the I minus I, that's 0, and then plus 1 minus 6, that's minus 6, mean minus 5, so that's minus 5 over 10, and then minus 5i over 10, meaning we can have minus half plus 3i over 2, 5 into 10, that's 1 over 2, and that's I over 2. So now we put the real part together, minus half, that's negative 1. And 2 common denominator, 2 into 2, 1, so we get 3i. 2 into 2, 1, so we get minus I. That gives us 2i over 2, which is I, like that. You see? Very nice to do if you just follow the I multiplication. And just go to question 9, which is our second example. Example 2. So, and y. A x plus I multiplied by 4 is equal to 8. X plus iy multiplied by 4i is equal to 8. So since we're looking for x and y, the first thing we do is we divide the 4. We divide the 4. So that we remain with x plus iy is equal to 8 over 4. In fact, that 8 over 4, 4 into 8 can go twice. So it will be 2. It will now be 2 over I. And then we conjugate. So conjugate, we multiply by negative. We are going to have x plus iy is equal to I times I down, negative times negative, we get positive 1. Positive 1 into 2, that's 2. So we have minus. Now, two complex numbers are equal if and only if I have a plus bi here, and then I have x plus iy there, it means that a is equal to x, b is equal to y. We want those things to be equal. The ones that have i's must be equal. The ones that don't have i's should be equal. So in this case, we don't have anything on the right that doesn't have I, meaning it's 0. And then y, we have a negative. So we leave out the i's now because even the y had I. So we left it out. You see? B, 1 over x plus iy. plus 1 over 1 plus 3i is equal to 1. So we take this data set. We have 1 over x plus iy is equal to 1 minus 1 over 1 plus 3i. Okay, like that. Then we'll get this, the common denominator there, 1 plus 3i, and then 1 into 1 plus 3i by 1, we get 1 plus 3i minus 1. You see, this tells us that on top there, 1 minus 1 is 0. So we remain with 3i up. So we have 1 over x plus iy is equal to 3i over 1 plus 3i. And then I'm bringing it here. So we cross multiply, we're going to have 1. We're going to have, when you cross multiply, we're going to have 3i multiplied by x plus iy is equal to 1 plus 3i. And then we divide by 3i, we divide by 3i. Because you want to remain with x plus iy. So we'll conjugate here by minus 3i. Here by minus 3i. So we'll have minus 3i plus 9 over positive 9, positive 9. So that we have 1 minus I over 3. So meaning that x is equal to 1 and y is equal to minus 1 over 3. Like this.
Sir, I don't know the method that you are using to solve those things, but I also got the same answers. Now the method of how you are using to solve, I don't know.
Here I've just used the fraction method, where you put fractions together, then cross multiply to have what you want to remain with on the other side. Because look, the x plus iy, that part was in the denominator. So we need to push it in the numerator. That's why I had to cross multiply and then later on divide it. So you see, it's not even that complicated.
So, sir, which method is better than the one for getting the common denominator first, and then from there you cross multiply, or this one that you've used?
The one for getting the computer.
The one for
You mean on which question?
this same question. The question is one of
not getting the common denominator there. You take the constant the other side, the numbers, then remain with the x and y this side. It's easy.
Okay.
Okay. So complex numbers. Maybe what I'll do now is because this story sheet. Okay, we'll discuss again later. Maybe wait until they mention the discovery. For now, we'll keep doing this story sheet until we feel bored of it, because there are some more questions that we need to do. For example, the rational and irrational things, and then some sets, interval shading, and then maybe we'll also do the sides, and then we'll be done with topic 1. And then by then story sheet 2 would have come out. So then we'll start doing functions. But look, guys, this set story sheet is not that much complicated. I expect each one of you to have attempted and have the solutions. That's how you do math. You solve and have solutions, whether they are wrong or they are correct. So that when we are discussing here, then you can know that, oh, there I didn't do this, but I got this. Yeah, it's different. Then where did I go wrong? Or if it's the same, like Esther saying, no, I did this, but I got the same answer, but I did a different way. Then you compare which way looks easier. Or do I understand this way also? So that depending on questions, maybe other questions will need this way. Then you're able to put things together. Otherwise, it was a good having this class with you guys. We continue having them daily for now. So tomorrow, since it's not the holiday, we should have a concert. So at least the students just set alarms and adjust their times. Good day.
All right, sir. Thank you.
Thank you. Good.